Now we're going to begin the review for test 2. And test 2 is going to cover chapters 10, 11, and 12. And again, what you'll do is you'll enter your answer into the Nearpod window. That'll let you proceed with the review. And then afterwards, you'll also enter your answer into the Canvas discussion. And you'll enter it with the chapter number. So for example, chapter 1, and also the number. And that'll give you credit for the discussion. Okay, so let's begin. Chapter 10 review. So here's the first question, chapter 10, number 1. So read these and decide which statement is correct. Okay, so let's see which statement is correct here. It's, as sea level drops, sea levels drop when ice sheets expand. So it's just sea level drops, ice sheets expand. The reason why is this is the Earth, this is the bottom of the ocean, and this is the ocean here. So water is constantly evaporating, and it rains on land, and normally it'll go back into the ocean, and that continues the cycle. Unless if the water turns into a glacier or turns into ice, so there the water stays on the land as ice and it doesn't go back into the ocean, but water is continually evaporating, and what that means then is that water is continually leaving, and so ocean level is going to drop as the ice sheets expand. Well, ice sheets and glaciers. Okay, next question. Chapter 10, number 2. What are some causes of ice ages? And the key word here is geologic time. So there are two kinds of ice ages that we're going to be looking at, but we're talking about long-term ice ages. Okay, so let's check the answer. What are the causes for long-term ice ages? And it's actually all of these. Let's see why. So for example, in the past, most of the continents were concentrated at the South Pole. So that meant that there was a lot of land in a cold area, and a lot of land meant a lot of places for ice to form, and a lot of ice cooled the planet down. And this occurred, plate tectonics take millions of years to occur, so these cause long-term ice ages. At the same time, let's see here. These are all related in some ways. Ice is white, and white surfaces reflect sunlight, so that the sun comes in, it bounces off the white ice and gets just ejected back into outer space. So that means that more heat is reflected, which also cools the environment down. Next thing is ice. Even ice itself can actually trap carbon dioxide. So that means that the more ice there is, the less carbon dioxide there is in the atmosphere, and less carbon dioxide also are going to cause temperatures to drop. So because of that, it's all of these here, and also changes in ocean current can also affect ice ages. Okay. So next question, chapter 10, number 3. Greenland and Antarctica cover how much of the Earth's surface today? How much of the Earth's surface is covered in ice today? And it's 10%. Alright, chapter 10, number 4. So here you have two parts. Part A, let's say this is the upper layer. How do glaciers move? Part A, the upper layer, and part B, the lower layer. So what are the two ways that glaciers move? Okay, so let's look at it. Let's start with the lower layer first. So the lower layer, you have all the ice pressing down onto the ground, and all that mass is causing a lot of friction at the bottom, and friction generates heat, and heat melts ice. So that means that at the bottom of the glacier you have a thin sheet of water. You can see it there, and that means that the whole bulk of ice can just slide down this thin sheet of water. So the lower layer, the entire ice mass slides on a thin sheet of water. So slides on a thin sheet of water. And the upper layer is exposed to the atmosphere. So that means that it's exposed to snow. So year by year, you get different layers of snow that form. And each of these layers are moleculistic, and they can slide past each other. So in the upper layer, you have these ice layers that are we'll say these thin ice layers, moleculistic, can slide past each other. Okay, chapter 10, number 5. So this is a pretty general question. What would happen if all the ice were to melt today? So look at where we are here. So if all the ice were to melt, sea level would rise, but also coastal cities are going to get flooded. Many coastal cities will be flooded. Okay, next question, chapter 10, number 6. How do glaciers acquire sediment? So you can see at the bottom of the glacier here, there's sediment, but large sediment, can be as big as boulders. So how do glaciers acquire sediment? And glaciers acquire sediment by a process called plucking. So what happens is that you have a boulder on the ground, and then the glacier passes by, and a thin layer of water beneath the glacier, goes over the boulder, freezes, and then sucks the rock up into the glacier. Plucking. Okay, next question, chapter 10, number 7. What was global sea level during the last glacial maximum compared to today? So with this picture you can see, these are hints there. So the sea level around 18,000 years ago during the last glacial maximum was 100 meters lower than it is today. Okay, next question, chapter 10, number 8. So this is the other kind of ice age. These are short-term ice ages that come every 100,000 years. So what are the cause of the 100,000 year ice age cycle? So the cyclic 100,000 year ice age cycle is caused by changes in the Earth's orbit. So the Earth's orbit fluctuates around every 100,000 years, so it's a little bit farther, and then it's a little bit closer, and so that causes ice ages to come and go. Okay, so this completes the review for Chapter 10.